We'll now consider a few things. We'll start with the perpendicular bisector. For a perpendicular bisector, we need to start with a line segment. And we had talked before about the midpoint construction theorem, which says we can always find the midpoint M. Well, we want a line that passes through this point M that is also perpendicular to our segment. And this would be known as the perpendicular bisector. It needs to bisect, meaning pass through the midpoint, and it needs to be perpendicular. The perpendicular bisector theorem says that if we're given any two points A and B, the locus of points equidistant from A and B is the perpendicular bisector. This means that every point on the perpendicular bisector has the same distance from A and from B. And if any point satisfies that the distance between A and this point and the distance between B and this point is the same, it will be on that perpendicular bisector. So we're going to let L be the perpendicular bisector of the segment AB, and M is the midpoint. So our line L, the perpendicular bisector, intersects this segment at M. We're going to start by letting P be any point on our line L. And then I'm going to consider these segments AP and PB. We then know by definition of the midpoint that the distance between A and M and the distance between M and B are the same. We also know this angle AMP and this angle PMB are the same since they're both 90 degrees. And the segment PM is congruent with itself. By side angle side, we know that triangle AMP is congruent to triangle BMP. Since they're congruent, we know that those third sides have to be the same. AP is equal to PB. So the distance between AMP and the distance between BMP are the same, which is exactly what we needed. We now want to show the other direction. This time we're going to suppose that PA is equal to PB. And we want to show that the point P does actually need to be on that line L. By Isosceles triangle theorem, angle PAM has to be congruent to PBM. And definition of the midpoint says AM is equal to MB. By side angle side, we then have that triangle PAM is congruent to triangle PBM. That then gives us that since corresponding parts have to be congruent, the measure of angle AMP is equal to the measure of angle PMB. Since the only way for that to happen would be if each of those angles were 90 degrees, we know that PM is perpendicular to AB. And since perpendicular lines at a point are unique, we have that PM is equal to our line L, so P must be on L.